We are going to talk about electrostatic. So, right. Electrostatic is the study of electric charge and at rest and the forces between them. So, electrostatic force is the study of electric charges at rest. So, what you have to take note here, electrostatic is the study of charges, mostly related to the study of charges and force between them. So, this electrostatic is a part of electromagnetism. So this electrostatic is a part of magnetism, which study magnetic and electric attraction. We study electric and magnetic attraction. So electrostatic is the study of electric charge at rest and forces between them. Electrostatic is a part of electromagnetism. We study magnetic and electric interaction. Yet. So what we have to note, take note, matter is made up of tiny particles. Matter is made up of tiny particles that carry electric charge. We know the definition of matter now. What's matter? Some people will not know it, so I know that. So I said that matters are made up of tiny particles that carry electric charge. So now we'll talk about the type of charge. We know that matter is made up of tiny particles that carry charge. So now let's talk about the type of charge. You know, very easy now, positive charge and what? Negative charge. So positive charge and negative charge. Now we have to know the fundamental of this charge. Like charge repel each other. Why what? Unlike charge what? Attracts. Take note. So like charge repel each other. But if you go to current, you know it's different. Yes. Let me just write it. Like, yeah. So I can give a different type of example why electric charge can be generated. If you use a comb to rub your hair, like rub your hair, then put in a piece of paper, you see it like it attracts. You know that. Yes, so that's an example. Another example is like clothes sticking together after drying are caused by static electricity. You know a lot of examples. So let's move on the structure of matter and electric charge. Structure of matter. We have to do just to follow by God's grace. We go to cover a lot before exam. Everybody can testify what happened last semester now. Everybody can testify. That semester we were not even like, you didn't start early. We were able to like cover a lot. So atoms are made up of particles. These particles are electron, proton, neutron. You know that already. So electron, is it positive or negative? Yes, negative. You can write it. And where is it located? Yes, around the nucleus. So take note. Why proton? Where is it located? Proton. Yes. Why neutron? So take note. So take note. They can ask you which of these form the nucleus. Which of these form the nucleus? Take note. Proton and neutrons form the nucleus. Proton and neutron forms the nucleus. Is it showing green light? Okay. Take note. So how will I put it now? Okay, normally the nucleus is kind of neutral because of the number of proton. It's because of the number of what? Electron. Take note of that. Take note as well. So let's move on to conductors, insulator, and semiconductor. Eh? Take note, the mass of all this is constant. Mass of electron is 9.1089 times 10 raised to the power of minus 31. So which one is heavier? Which one is heavier? Yeah. Neutron 1.6. They can't be electron because it's minus now. Which one is heavier? It can't be electron because yes, somebody say electron. I'm trying to explain because of the minus. If you change it, it will be close to 0.0000 something. So it's a neutron. Take note. Okay, before I move on to the fundamental principle of concerning charge, I want to write conductors, insulators, and semiconductor. Conductors allow charges to move freely. Conductors allow charge to move freely. Conductors allow charge to move freely. Example, we have metals. Metals allow charge to move freely, right? We have a copper wire. We have a. You can use yourself for example. If I put electric, it will pass through you. You get. So, right, insulator. Insulator do not allow charge to move easily. Example, plastic, rubbers, wood. Then semiconductor, from the word semi, like partially. So it's like you have property between the conductors and the insulator. Get example of semiconductor. I think they are mainly tetravalent. Get example. Is silicon a semiconductor?
Yes.
Is germanium a semiconductor? Okay. Ionization. Now, let me say a neutral atom now can be charged if it gains electron or loses electron. Like an atom now can be charged if it gains electron or loses electron. So you're right, ionization, ionization. The atom, an atom becomes charged when it gains or loses electron. Let's answer this. If an atom loses electron, is it going to be positively charged or negatively charged? Right? Why if it's gain, it's going to be what? Take notes. Very important. All these small things, I was not a faint person. Ionization. Okay, I said that an atom becomes charged when it gains or loses electron. If it loses electron, it becomes positively charged. Why if it gains electron, it becomes negatively charged? Let me give an example. If you have a balloon, then you rub it on your hair, you can clearly see that electron will pass through from your hair to the balloon. Then the balloon will be what? Is it negatively charged or positively charged? Yes, balloon will be negatively charged, while your hair will not be what? Positively charged. You can clearly see. Understand? That's why if you do that thing, if you put balloon on the wall, it's going to stick. Have you noticed it? Or you have not tried it? You just take note about that. This is an example. Okay, let's talk about during lightning. Lightning. During lightning, charges move from the cloud to the ground. The total charge will remain conserved. During lightning, charges move between clouds and the ground. Total charge remain conserved. From the clouds, yes, and the ground. Like, are you okay? Conserve. Charges exist. Quantization of charge. Charges exist in discrete units. Charges exist in discrete units. Charges exist in discrete units. E equals to 1.602 times 10 to the power minus 6 coulomb. Then Q equals to NE. Take note of this formula. Q equals to NE. N is what? the integer. E is what? Elementary charge. Q, you know Q now. Q is the total charge. Take note, Q equals to what? Ne. Charges come in a disc how will I put it now? Charges comes in packets, not fractions. Like now, let me give you an example. Like if you want to buy apple now, this you want to buy half apple. You say you want to buy one apple, two apples, three apples. Yeah. So you can take that instant as charges. You can't like have a charge. You understand? Like how will I explain it? Charge must come as packet. Just take note of that. So let's take one example. Said They said the charge on a particle is 2 times 10 raised power of minus 4 coulomb. Determine the charge quantum number. The charge of a particle is 2 times 10 raised power minus 4. Say that is 2 times 10 raised power of minus 4 coulomb. That's the Q. Say you should find the what? Find the number. Determine the charge quantum number. So we're looking for what? N. So what's the answer? Hope you come with our calculator. Your calculator. 1 times 10. 1 times 10 power of minus 15, not, is it minus 15 or 15? Okay, 15. Don't understand. Everybody understand this? Everybody understand? From the formula, Q equals to NE. Let's make E subject of, no, N subject of formula. Divide both side by what? E. So when we divide both side to be Q over what? E equals to what? N, which is the elementary charge. We're looking for this. So our Q is what? 2 times 10 power of minus 4. And our E is what? 1.6 times 10, 0.2 times 10 power of minus 19. When you do it, you have what? You have 1 point what? 1 times 10 power of 15. Is it 1 times 10 power of 15 or 1.25 times 10 power of 15? Don't understand. Can we solve? Let's solve. Let's solve this one before we go to Coulomb's law. Let's solve this question before we go to Coulomb's law. They say lightning occurs when there's a flow of electric charge between the ground and a thundercloud. The maximum rate of charge flow in a lightning bolt is about 20,000 coulomb. This lasts for 100 mu. Is it mu? That's that. 100 milliseconds. You see mu? Eh? Yes. Or less. How much charge flows between the ground and the cloud in this time? How many electrons flow during this time? This question is like 2 in 1. So what are we going to do? Say the flow of charge is called current I. So the rate of change, which is, you know that Q equals to IT. So now the rate of change equals to the dQ over dt. That's the rate of change. Is it the same thing as Q over D? It's just like they gave us the change, rate of change already. You understand? Most time they will not give you, might give you 2, and you have to like minus. But okay. And that's what I'm saying, is the same thing you get. So the SI unit of current is in ampere, right? So therefore, if the SI unit of this is ampere, time is in what? Second. This one is coulomb self, right? So therefore, we can say that this amperes equals to what? Coulomb per what? Second. Do you understand? You say that ampere, which is the current, is equals to the Q over T. And you know that Q is what? Measured in coulomb, and T is measured in second. Therefore, we can say that the ampere, which is SI unit of current, is equals to the coulomb per what? Second. Take it. You can actually find it. Which they did here. I'm just trying to explain. So let's solve. Let's solve for Q. We already have our current and time, right? No. Sorry. Coulomb per second, which is the ampere. You can clearly see the coulomb per second is ampere here. So we're looking for Q. Let's solve for Q. Q is IT. So what? You know that mu is what? 10 raised power of what? 6. Sorry, minus 6. So therefore, we're going to say that current here is what? 20,000 times time is 100 times 10 raised power of minus 6. So our Q here is what? Well, our Q here is what? 2. 2 what? Hold on. So don't understand. You understand? So now let's find the number of electron. That's the N. Let's find N. You said that what? Q equals to what? Ne. So let's find N. N is what? Q equals to what? Over E, which is N. Very easy. What's the answer? Q is, where is Q? Q is 2. E is what? E is constant, right? Times 10 is power what? Minus what? So the answer is what? Minus what? 90. Is that clear? Okay. Is that clear? There's another question here. Should we solve it? Or should we just go to Coulomb's law? Okay, we should solve it. They said, what is the total charge in coulombs of all the electron in 3 mole of hydrogen atoms? It's very easy. From next week, I'll try to like be consistent because I was kind of sick. That's why I was not consistent in chemistry. We should be consistent so that we can cover like every day. Like I think, let me say 2 days, depending on the chapter, how long it is. We do one chapter for 2 days or one chapter 1 day. Eh? So what is the total charge in coulombs of all the electron in 3 moles of hydrogen atom. 3 moles. So now we're going to go to, have you heard about Avogadro's constant, right? So now, say that 1 mole of hydrogen give you, contains 6.022 times 10 to the power of 23 atoms. So if 1 mole of this H2 contain this, 3 mole of hydrogen atom will contain what? It contain X, right? So it will not be cross multiply. It will not be X, 1 mole X equals to 6.022 times 10 to the power of 23 atoms times 3 mole, which will give you S is what? Do it. Come again. 1.806 times 10 to the power of what? 24. So therefore, we can say the number of electron in 3 mole of hydrogen is what? Is this. So now, what they ask us? Okay, look for Q, right? So let's use our formula. Q equals to what? Ne. You know, N is E is constant. So N is what? This, which is this. So it's 1.806 times 10 to the power of 24 times. So the answer is what? 2.98.
Oh, not 2 points. 89321.
Is it correct? Before exam, make sure you solve all the exercise and the example, everything. Make sure you solve each question you get, because they are going to be built from there. There's no way they are not going to set from there. Make sure you don't miss any question. Very important. Eh? Which topic? Chapter 2. Which one? I will finish chapter 1 today. You're not long down. No. Just chapter 1 today. Then I'll do a quiz. This happen. We'll do chapter 2, don't worry. We'll finish everything. From next week, when school have like everybody have doing Sunday as well. Saturday, then Saturday first. No rest, no. Okay, let's move to Coulomb's law. Is it showing green? Is it showing green? So Coulomb's law is explaining the force between two charge. Coulomb's law is talking about the force between what? Two charge. Coulomb's law explains the force between two charge. F equals to K Q2 over what? The F here is what? The electric what? Force, right? Q is what? The charges. charges. Arrow is what? Arrow is the distance between what? Two charges. Take note, K is constant. Column constant. K is constant. Okay, from our book, it said that Coulomb's law state that the magnitude of the electric force. Okay. Coulomb's law state that the magnitude of the electric force between 2-point charges is directly proportional to the product of the charge and inversely proportional to the square of the distance between them. Okay, he said that Coulomb's law state that the magnitude of this electric force is directly proportional to the charges between them and inversely proportional to the distance, the square of the distance. It's very easy. No, you don't even need to cram this. It's directly proportional to the product of the charges. Hope you understand it. When we say something is directly proportional to something, then we say like, um, okay, say pressure is directly proportional to temperature. If pressure increases, temperature will increases. While if pressure decreases, temperature increases. That's called directly. And this one is going up. I'm following it. While inversely is, oh, yes, it's like 1 over. This one increase, this one what? Reduce. So now, say that the force, which is the electric force, is directly proportional to the product of the charges, which is the Q1 and Q2, and inversely proportional to the square of what? The distance. That's all. Get. K is constant, which is this K. So it's normally it's going to be like this. F inversely directly proportional to Q1, Q2 over R1. I don't know if you have do a mass, there's something. If you want to remove this, you introduce a constant, which is this K. You understand? So the K is the Coulomb constant. Very easy. So, so K is what? 4 over what? Is it correct? Or what? 9, is it? I see. 9 times 10 minus 9 or 9. Newton, what? Newton meter square per column. Per column square. Newton meter square per column square. This thing can be, we can prove it. So if you use here force MA, then Q, C, arrow distance. If we prove it, we go to derive here. So I don't want to make it long. We can prove. You just play through it. You understand? So this, so the meaning of this formula is when the force is increased, the charge what? Increase as well, right? While if the force is decreased, the charge what? Okay, force decreases, the distance what? Increase, right? So you can take note of that. You can write it. It's your note. You can take note, but that's very important. I'm just explaining. Okay, let me explain something. I talked about balloon. When you rub balloon on your hair, it becomes negatively charged, right? So now you have 2 balloons. You rub it on your hair. They both become negatively charged, right? If you bring them together, are they going to attract or repel? They're going to repel, right? So use that as an instant. But if you bring one and stick it to the wall, it's going to stick, right? I wish balloons they would have done it. So now we're going to talk about take note. This E is permittivity of what? Medium. Permittivity of what? Medium, which is what? In free space, E is what? EO. While EO is what? 8.854 times 10 is the power of minus 12. Most time, you need to know all these constants. Most time, in equation, they'll put it beside the equation. I don't, but just try and know it. Or try to be familiar with it so that if you see question like that, you can be able to know. Most time, they will give you question. They'll add different this thing. You don't even need to use the parameters. Take notes. Superposition principle. Superposition principle. Superposition principle. When anyway, it is superposition principle. Make sure you are subscribed. Codesolution.com. Are you subscribed? Are you subscribed? Codesolution.com. Yeah. When you are free, just subscribe. Code. Are you subscribed? Subscribe. 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 For this class. Code me. Okay, now this superposition is talking about when many charges exist together. When many charges exist together, total force is equal to the vector sum of all force. Total force is equal to the sum of all vectors. Vector force, like total force is equal to vector sum of all forces. Now, let's see in our textbook, it said that the net force experienced by any charge, say Qi, is the vector sum of the force it will experience by interacting with other. So according to this principle, it said that F1, Q1, Q2 over R1, no, 2, plus K, Q1, Q3 over R1, 3. So take note, just take note of what is changing. This change, this one, this remain constant. So we can therefore say that, we can go further, say that K, Q1, Qn over R1, N. You can clearly see that this N, what is here will be here. You understand? So if here is F1, so F1 have 1 here, they have 2 here, F2 have 3, and so on and so forth. Hope you understand.
Why is this so just like additional?
Eh?
Why is electricity? That is just like a gravitational force.
Why
Why is there like gravitational force?
electrostatic is like gravitation?
Like similar, same their formula is looking similar.
Okay, because they talked about attractions, gravitational force of attraction. You can see this attraction is there, and there will be a force. There will be an attraction between a mass, two body. This one is a charge, two body. You understand? Yes, so there must be attraction, gravitational force, and this. So let's move on. Okay, what should I say to explain this now? Okay, now imagine different people pulling rope from a different direction. You get you can like the amount of this now. If you pull here, pull here, pull here, pull here, pull here. I'm trying to like find a way to explain it. The like uh total forces, like if like three forces is more than the other, it's going to put to the direction. You understand? Yes, that's what I'm just looking for a way to explain it. Please, I'm come on, let me answer this call.
If you don't collect it, wait, I don't
So what's the name? Yeah, because I'm trying to see I don't want the group. So take note of this. Where is this? Where is the column constant? So I write column constant. Okay, take note of this and take note of this. You know it. These two. You can still it to your book. Take note of it. Take note, the force depend on the size of charges. The force depend on the size of charges. The force depend on the size of charges, which means the bigger charge, the stronger what? The force. The force now depend on the size of the charges. So the bigger force, the stronger the charges. So if I apply force, like I'm just using myself as example, it also depend on the distance. If this charge Q1 and this charge Q2 are far apart, is it going to be weaker or stronger? It's going to be weak, right? Because they're far apart. Why if they're close? It's going to be stronger. Take notes. So now let's move to effect of medium. Effect of medium, open bracket, dielectric. Effect of medium, open bracket, dielectric. Hope you are using a separate note for this. Hope you are using a separate note so that you will not mix it up. I saw something. K equals to K naught over PRO. K equals to. Take note, in real life, charges are not only occur in air or vacuum. So I can modify Coulomb's law to something like this. Let me modify it. So I can modify F equals to KO. Rema. Rema. Yes. Yes, constant. No, no. I can say something like this. If K, where's our Rema formula? K is this now. Can you create this into here? You understand? That's what I did there. Get. PRO is dielectric force, right? Dielectric constant. PRO is dielectric constant. So this dielectric constant, it reduces the force. It's like trying to talk underwater. To be hard for you to talk underwater. To be hard for you to talk underwater, right? Yes. Yes. If you try to talk underwater, there will be like a weaker interaction. To be harder, so there will be a weaker interaction. If you want to talk like now, air, to be very easy. So there will be stronger interaction. So take note, electricity behaves differently in air, water, and oil. Electricity behaves differently in air, water, and oil. That's why transformer uses oil to reduce unwanted electric effects. Transformer will use oil to reduce unwanted effects. So now let's solve one question. So it said that what is the magnitude of the Coulomb big force between 2-point charges? What is the magnitude of the Coulombic force between 2-point charges? Q1 equals to minus 2.00 mu coulomb, and Q2 equals to plus 3.5 mu coulomb, separated from each other by a distance of 15 centimeter in air. By a distance of 15 centimeter in air. What is the natural, so what is the nature of the force? First thing, solving question, write your parameters out for you to be able to like solve the question and not make mistake. So our Q1 here is what? Minus 2 what? Mu coulomb. Q2 is what? Plus 3 point what? While our arrow is what? You will not solve with centimeter, you solve what? With meter. So if you want to convert 15 centimeter to meter, we divide by what? So it will now be 0.15, right? Put this in the back of your head. Oh. Okay, let me ask this question. Are the charge same or opposite? Are the charge same or opposite? So they will attract or repel? Attract, right? Okay, let's solve. Very easy. F is equals to F K Q1 Q2 by what? Arrow what? Square. Arrow square is what? 0.152. K is what? 9 times 10 to the power minus 9. Q1 is what? What? Okay. Times 3.5 times 10 to the power minus 6 plus minus 6, right? Is it correct? Indices. It's correct in indices now. So, what's the total answer? This will cancel already now. Minus 6 plus minus, oh no, minus 6 plus minus 6 is what? Minus 12. So we'll do it. Minus 12, 10 times. Let's just do everything for me. Do everything with your calculator. Make sure you do it in your calculator. Don't use the book because you're looking at the book. Do it. I know why I'm saying you should do it so that you're used to it. Do it in your calculator. Even though it's in the book, so that your brain is used to it. So the answer is what? You can do this part, do this part, do this part, leave this part, then do this part. And when I'm done, do it. What's the answer? Since the charges are different now, they're going to attract, right? What am I supposed to write there? Okay. Do you know if this word that is stationary like this, if I apply force and press the word, the word is also pressing me back. Do you know? Do you know? Take notes. So let's move. take note. Under this superposition, talk about multiple charge. Take note. When more than two charges exist, when more than two charges exist, total force is equal to the sum of all forces. When more than two charges exist, the total force is the sum of what? All forces. What? The total force is equal to, total force is equal to sum of all forces. So imagine you are being pulled. What's the name? Pressure. Imagine you are being pulled by, what's the name? Faith. Are you pulled by faith? What's the name? Yes. Huh? Okay, Sharon and Ope Yemi. You are being pulled by then the combined, like you're going to move to the direction of the combined forces. So take notes. So your movements will depend on what? The combined what? Pull. So if you are being pulled by, like I'm using it as an example, you get. So now should we take one question before we move to this component part, or we should just go to the component part? That we should take the question, right? Okay, now let's take it. Two identical coins separated by a distance 2.5 meter. Two identical coins separated by a distance 2.5 meter in a large vast of liquid are carrying identical charges. If the dielectric constant of the liquid is 92, calculate 1. The magnitude of each charges if the repulsive electrostatic force is 40 Newton. 2. Find the number of electrons on each coin. So the first thing here, take notes. Identical coin. Identical coin. So two identical coin. The coin are identical. So can I say that the Q, the charges are identical as well because they are identical coins. So I can say that Q1 is equal to Q2 or equals to Q. You take note. So let's write our parameters. Our arrow is what? Arrow here is what? 2.5 what? Meter. Dielectric constant, which is what? Is it EO? EO is dielectric constant, right? ERO is what? 92. So find the magnitude of each charge if the repulsive electrostatic force is 40. F is what? 40 what? Newton. So now I say you should find the what? Magnitude, the magnitude of the charge, find the magnitude of each charge, so it's Q you are looking for. If you find Q, you can find Q is the same as Q1, Q2, because they're identical. So if you find Q, we also find this other one, you understand? So let's make Q subject of formula. So now, you know we can modify Coulomb's law. So this. Can we agree to this? We can agree to this, right? So if we modify it now, so let's make, since this one is the same, we can just put one Q here. So let's make Q subject of formula. So what we're going to do to make Q subject of formula? Cross multiply, right? I'm going to cross multiply. So when we cross, I take it as 1. No, I take it as 1 because it's identical. If you find 1, you also get the other one. Let me see what they did here. They did the same thing. So let's cross multiply. If we cross multiply, we know that F E arrow square is equal to what? K over what? Q. Divide both side by what? KO. It's Q square. So that Q is equal to Q1, Q2. So therefore, we can say Q is equal to Q.
No, Q1 and Q2 are two different things. So they are saying two identical points. So it's Q1 and Q2. You now use that number you use for Q1 and Q2. So you now Q square for using this one.
Okay. So let's use Q square. Yes. If Q2 is Q1, you can clearly put Q1 here. So Q1 is equal to Q square. You understand? So pardon me. So now let's make Q sorry to formula. It's going to be F E arrow square over what? KO equals to what? Q square. So once you cancel Q square, you what? Square both sides, right? Square root of both sides. This one will cancel this, right? This will now be Q is equals to square root of what? F E arrow square over what? K what? Oh. So now let's put our what? Value inside here. So now let's put it down. F is what? E arrow is what? Arrow square is what? 2.5 times 5. That's is eh? Do it now, just do it once. I don't want to like write it. 6 point what? Divided by KO. 9 times 10 is power of what? So let's do it. Everything or everything plus the square root. 1.6 times 10 is power of what? Minus 3. Okay. Minus 3 what? Hold on. So now I've gotten the first question. Do you understand? If you don't understand, let me know. You understand? Everybody understand, right? Everybody understand. It's easy. Understand? So the second question, it says you find the number of electrons on each coin. Number of electrons on each coin. You know the formula to use now. Q equals to NE, right? Well, let's solve it. Let's just solve it. Solve it and give me an answer. Very easy. Make sure you solve it. 9.97 times 10 is power of what? 9.97 times 10 is power. 9.97 times 10 is power of 15. In our book, depending on the option, if you see 9.97, you pick it. If you see 10, 1, if you see 10 times 10 is power of 10. Convert this into, if it took whole number, this will be 10, right? Like 10 now, right? So if this is 10, I think you move here to change here to 16. It's in indices. I don't know if you do indices. You move one step forward to change here to 16, then it will not take whole number. I think that's what they did there. Let me see. Do you understand? So it will now be 1. If you move here, it will now be 1. You understand? Change here to. You understand now? So 10, 15, move. So it will be 1 times 10 is power of what? 16. Depending on the option. So now let's move. Hope everybody understand. So let's move to breaking forces into components. Let's take this already. Breaking forces into components. Breaking forces into components. This part is where people struggle a lot. Like this particular part, people struggle a lot in this part.